In this tutorial, we're going to be looking at a different type of example, an example where we need to use sine, cos or tan to find an unknown angle rather than an unknown side. If you look at the example that we have in front of us here, this is the sort of example you would be completing if you had to find the unknown angle. If you have a look at the right angle triangle that we've got here, in this example, we know two of the sides in our right angle triangle. We know that the hypotenuse here is equal to 5 centimetres, and we know that the vertical side here is 3.5 centimetres. What we don't know is the size of this angle. Now, in order to find the size of this angle, we need to use the same sort of process as we've done before, but there is a slight difference. In this example, instead of finding an unknown side and knowing the angle or the value of the angle, we now have to find the value of the angle when we know two sides. So let's look at this example now. First of all, let's look at where our angle is situated. It's down here. And if we look at the two sides that we know, the 3.5 centimetre side is opposite the angle, and the 5 centimetre side is opposite the right angle, which means that this has to be the hypotenuse. So we have the opposite side and the hypotenuse, so we need to work out which trig ratio are we going to use to solve this problem. Now, the ratio that uses the opposite side and the hypotenuse is sine. So in this case, our first line of working is going to look like this. We have sine of our angle, and we don't know what it is, so we're just going to call it theta, is equal to the opposite side over the hypotenuse. Now, if we look at our triangle, let's now insert the values of our sides into our equation. So sine of the angle is equal to 3.5, that's the opposite side, over the hypotenuse, which is 5. Now, on our calculator, we're now going to find the value of our 3.5 divided by 5. Now, so let's turn on our calculator. We're going to do 3.5 divided by 5, and that's going to give us 0.7. So this means that sine of the angle will be equal to 0.7. Now, this is where things start to change. In the past, we knew what our angle was, and we used our ratio to find an unknown side. Now we're using our trig ratio to find the angle. Now, when we find the angle, we need to work backwards from our trig ratio. We know our trig ratio is equal to 0.7. So we have to work backwards to find the angle. Now, in order to do this, we use a special function on our calculator which is called inverse sine. An inverse sine is written like this. We write it as sine to the power of -1. That's what we call inverse sine. Now, you can do the same with all the other ratios. So inverse cos is cos to the -1. Inverse tan is tan to the -1. So our next line of working is going to look like this. Our angle is equal to inverse sine That's how we write it. Sine to the power of -1, inverse sine of 0.7. Now, to calculate this, we're going to use our calculator. So here it is again, and what I'm going to do is I'm going to clear my screen and we're going to find inverse sine. So where is inverse sine on our calculator? Now, first of all, let's have a look at where sine, cos and tan are situated on our calculator. We already know where that is. Now, if you notice above the sine button here, in yellow we have printed sine -1. This is our inverse sine function, and it's in yellow, which means that we need to use this yellow button up here, our second function, to use sine to the -1. You'll notice that above cos, we also have cos to the -1 in yellow. Above tan, we have tan to the -1 in yellow. So all of our inverse sine, inverse tan, and inverse cos functions are above the sine and cos and tan buttons in yellow. And in order to use them, what we do is we press the second function first, and then we're going to press sine. And notice now how my calculator shows sine to the -1. Now I'm going to put in the value of my trig ratio, 0.7, and then I'm going to hit equals. And there is my angle, 44.427 degrees. So we have 44.427 degrees. Now, we could give that answer to any level of accuracy that we want. We can give it to 2 decimal places, which means it would be 44.43. We have to round up. Because our third digit is 7, we have to add 1 to the 2 and make it 0.43. If we wanted to write it to 1 decimal place, it would be 44.4. If we wanted to round it to the nearest whole degree, we would round down to 44 degrees. So there is my angle. I would suggest that when you come up with your angle, round it down or up to the nearest whole degree. So in this triangle, the angle is equal to 44 degrees. Now, let's just quickly revise in order to find an angle. Say, for example, I've got an angle and I know that tan of theta is equal to 1.53, and I want to work out the angle. Let's revise what we do on our calculator. We're going to go to second. We're going to hit tan, and this gives us tan to the -1, and we're going to put in our ratio 1.53. Now remember, we have to put in our line of working. So we need to say that theta is equal to inverse tan of 1.53. Now I can work out what my angle is. Now I've already done that on my calculator. Let's see what the answer is. So I'm going to hit equals, and I get 56.83 degrees. Now if I'm going to round that to the nearest whole number or whole degree, I'm going to round up to 57 degrees. And that's my answer. Okay, that's our tutorial on finding an angle from a trig ratio. I hope you found it helpful.